Okay, so let's move on. So what I want to do next is that now we have collected a lot of information about quantum mechanics, and I want to move on and discuss some real life, like real concrete physical situation. But before we do that, we want to just, present quantum mechanics axiomatically. And the presentation that I'm going to make, it's not necessarily the most abstract or the most minimal formulation. I'm not going to care about, whether all the axioms are strictly independent of each other, but, I just want you to have a glimpse at the underlying structure of quantum mechanics, okay? All right, so let's start. Number one, the physical state of a system is described by a complex L2 integrable function. Okay? So the physical state of a system is described by an L2 integrable in a complex wave function. And if, let's call it psi x of t, or say phi x of t. No, it's just a symbol. You don't have to use Greek letters. Okay. So what does L2 integrability mean? So L2 integrability implies that if you take your wave function and take its modulus and square it, and if you integrate it over the whole volume of space, physical space, let's call it R3, then that is that you get a normalized, normalization function n, where n is finite. Okay. So n, of course, is real, as you should see from this definition. The integrand is real. So n is real, of course. Not only is it real, it's actually positive, right? But L2 integrability means that it also needs to be finite. So if it's finite, that means that we can, this is also part of the axiom, we can replace psi by psi divided by, say, square root of n. Okay, this is a valid wave function, and this wave function is then normalized. But also, let's call this, say, I don't know, let's call this, say, capital psi for now. The other thing is that we chose square root of n to be real, right? But this result tells us we could have chosen this normalization to be square root of n times a phase, right? Would that change anything, a constant phase?
No, sir.
Yeah. So that means that, this wave function, this normalized wave function, capital psi, x of psi, we are actually identifying that to another wave function times some constant phase. Okay? Phi is a real constant. Okay. So, after having said that, what we can say is that, okay, this wasn't exactly the right statement, The right statement should be that the physical state of a system is described by a class of L2 complex wave function, that it's given by this whole, this is an equivalence class of wave functions, right?
Yes, sir.
So it's given by all, so they all represent the same state, okay? So this phase, this overall phase has no physical interpretation whatsoever. Okay? So this is a minor point, but I wanted to point it out. So once we have normalized it, then our wave function squared dx over R3 is going to give me 1. So this is our axiom number 1.